Thermal energy transformations. You can convert other forms of energy into thermal energy. Repeatedly stretching a rubber band makes it hot. Burning wood heats the air. A toaster gets hot when you turn it on. You can also convert thermal energy into other forms of energy. Burning coal can generate electricity. Thermostats transform thermal energy into mechanical energy that switch heaters on and off. When you convert energy from one form to another, you can use the energy to perform useful tasks. Remember that energy cannot be created or destroyed. Even though many devices transform energy from one form to another or transform energy from one place to another, the total amount of energy does not change. Red header, heating appliances. A device that converts electric energy into thermal energy is a heating appliance. Curling irons, coffee makers, and clothes irons are some examples of heating appliances. Other devices, such as computers and cell phones, also become warm when you use them. This is because some electric energy always is converted to thermal energy in an electric device. However, the thermal energy that most electronic devices generate is not used for any purpose. Red header, thermostats. You may have heard the air conditioning in your house or in your classroom turn on a hot day. After the room cools, the air conditioner turns off. A thermostat is a device that regulates the temperature of a system. Kitchen refrigerators, toasters, and ovens are all equipped with thermostats. Most thermostats used in air conditioning systems contain a bimetallic coil. A bimetallic coil is made of two types of metal joined together and bent into a coil, as shown in Figure 14. The metal on the inside of the coil expands and contracts more than the metal on the outside of the coil. After the room cools, the thermal energy in the air causes the bimetallic coil to curl slightly. This moves a switch that turns off the air conditioner. As the room warms, the metal on the inside of the coil expands more than the metal on the outside, uncurling the coil. This moves the switch in the other direction, turning on the air conditioner. Refrigerators. Red header, refrigerators. A device that uses electric energy to transfer thermal energy from a cooler location to a warmer location is called a refrigerator. Recall that thermal energy naturally flows from a warmer area to a cooler area. The opposite might seem impossible, but that is exactly how your refrigerator works. So how does a refrigerator move thermal energy from its cold inside to the warm outside? Pipes that surround the refrigerator are filled with a fluid called a coolant that flows through the pipes. Thermal energy from inside the refrigerator transfers to the coolant, keeping the inside of the refrigerator cold. Black header, vaporizing the coolant. A coolant is a substance that evaporates at a low temperature. In a refrigerator, a coolant is pumped through pipes on the inside and the outside of the refrigerator. The coolant, which begins as a liquid, passes through an expansion valve and cools. As the cold gas flows through pipes inside the refrigerator, It absorbs thermal energy from the refrigerator compartment and vaporizes. The coolant gas becomes warmer, and the inside of the refrigerator becomes cooler. Condensing the coolant. Blackheader, condensing the coolant. The coolant flows to an electric compressor at the bottom of the refrigerator. Here, the coolant is compressed or forced into a smaller space, which increases its thermal energy. Then, the gas is pumped through condenser coils. In the coils, the thermal energy of the gas is greater than that of the surrounding air. This causes thermal energy to flow from the coolant gas to the air behind the refrigerator. As thermal energy is removed from the gas, it condenses or becomes liquid. Then the liquid coolant is pumped up through the expansion valve. The cycle repeats. Red header heat engines. A typical automobile engine is a heat engine. A heat engine is a machine that converts thermal energy into mechanical energy. When a heat engine converts thermal energy into mechanical energy, the mechanical energy moves the vehicle. Most cars, buses, boats, trucks, and lawnmowers use a type of heat engine called an internal combustion engine. Figure 16 shows how one type of internal combustion engine converts thermal energy into mechanical energy. Perhaps you may have heard someone refer to a car as having a 6-cylinder engine. A cylinder is a tube with a piston that moves up and down. At one end of the cylinder, a spark ignites a fuel-air mixture. The ignited fuel-air mixture expands and pushes the piston down. This action occurs because the fuel's chemical energy converts to thermal energy. Some of the thermal energy immediately converts to mechanical energy. A heat engine is not efficient. Most automobile engines only convert about 20% of the chemical energy in gasoline into mechanical energy. The remaining energy from the gasoline is lost to the environment.